Today we are going to discuss about pressure vessels. So the main table of contents are what is pressure vessel, classification of pressure vessel, various types of ends or heads used, thin cylinder, thick cylinder, open and closed cylinder. And this open and closed cylinder usually not asked in exam. Just refer to this topic in the model content. So the main importance we have to given is thin cylinder and thick cylinder. So first one, what is a pressure vessel? A pressure vessel is a container designed to hold gases or liquid at a pressure substantially different from ambient pressure. So when designing a pressure vessel, the main things we have to consider is the volume of the pressure vessel, the outer diameter, inner diameter, and thickness. So based on different classification, according to dimension, it is thin and thick, and thin and thick difference means it is based on the ratio of d by t, and according to end construction it is open and closed. These are the various types of ends: hemispherical end, semi-ellipsoidal head, torus-spherical head, etc. So next we are going to discuss a problem, that is thin cylinder. Thin cylinder means the ratio of inner diameter to thickness is greater than 10. A seamless cylinder with a storage capacity of 0.025 meter cube is subjected to an internal pressure of 20 megapascal. The length of the cylinder is twice its internal diameter. The cylinder is made of plain carbon steel 20C8. Ultimate strength is equal to 390 Newton per mm square. And the factor of safety is 2.5. Determine the dimension of cylinder. Here you can see volume is given as 0.025 meter cube, internal pressure 20 megapascal, length is 2 times diameter, ultimate strength 390 Newton per mm square, factor of safety 2.5. When we are using volume is equal to pi by 4 into d square into L. Instead of L we can substitute 2 times di, so pi by 2 di cube, and di we are getting 250 mm. Upon getting di, length is equal to 2 times di, that is 500 mm. Then we are going for thickness of cylinder, that is sigma is equal to pdi by 2t. Here you can find two different equations for sigma, that is pdi by 2t and pdi by 4t. And when designing the thickness of cylinder, usually we are considering the equation which gives more stress. More stress means pdi by 2t. pdi by 2t is always greater than pdi by 4t. So we are considering this equation pdi by 2t. And sigma is equal to SUT by Fs. So upon substituting we are getting 156 Newton per mm square, and sigma is equal to pdi by 2t. We are substituting that and we are getting thickness as 16 mm. Next we are going for a consideration of thick cylinder, that is dA by t is less than 10. The piston rod of a hydraulic cylinder exerts an operating force of 10 kN. The friction force due to piston packing and stuffing box is equivalent to 10% of the operating force. The pressure in the cylinder is 10 megapascal. The cylinder is made of cast iron Fg200 and factor of safety is 5. Determine the diameter and thickness of cylinder. Here given internal pressure 10 megapascal, ultimate strength 200 Newton per mm square, factor of safety 5, piston force 10 kilonewton, and here we are considering friction also, means 10% of piston force. That is, when we are designing the diameter of the piston cylinder, when we are designing the diameter of cylinder, we have to consider the effect of piston force and also friction. So the total force will be 10 kilonewton by piston by plus 10% of piston force due to friction. So 10 plus 10% of piston force. So we are getting ultimately the total force acting on cylinder or piston is 11,000 Newton. So basic equation, force is equal to area into pressure. Force we know and pressure we know 10 megapascal. From that we are getting dA is equal to 37.4 mm. Upon getting dI we are find then thickness. Here it is given cast iron, so it is a brittle material. So corresponding to brittle material equation is T is equal to dI by 2 into sigma plus P by sigma minus P raised to 0.5 minus 1. Here sigma is SUT by Fs, so 40, and T from that we are getting T is equal to 6 mm. Next problem is a cast iron cylinder of internal diameter 20 mm and thickness of 50 mm is subject to a pressure of 5 Newton per mm square. Calculate the tangential and radial stress at the inner, middle and outer surface. So it is given inner diameter 200, thickness 50 mm, pressure 5 Newton per mm square. So outer diameter will be inner diameter plus 2 times thickness. So it is equal to 300 mm. Next tangent. This all equations are given in data book. Tangential stress at the inner surface. The equation given in page number 103. It is getting 13 megapascal. Middle surface. Middle surface means in this equation there is a term called R. Instead of R, we are substituting the middle radius. Okay, and the outer surface means instead of R, we are substituting RO, that is outer radius. So it is getting 9.76 and 8 megapascal. Next, you are finding radial stress in the inner surface minus Pi. So Pi is given 5 megapascal, so minus Pi minus 5 megapascal. And here minus 5 megapascal implies 5 megapascal compressive stress, right? Then plus means tensile stress, minus means compressive stress. And radial stress at the middle surface means instead of R, you just substitute the middle R value, the 1.76 megapascal, and outer means instead of R, you substitute RO. You can see here in the numerator 4RO square minus DO square, that is equal to 0. So radial stress at the outer surface will be equal to 0 megapascal. Thank you.